Hey everybody, Dave Lindbergh in Hong Kong with another episode of THD Podcast. Today we have a company joining us from Switzerland called EEDUN, and they're doing electroencephalogram technology, or EEG. And yes, I did practice saying that word earlier, so we're going to find out about this technology, but without delay. And it's basically they're embedding another sensor into earbuds and stuff. So that's why we're going to talk about it. But without delay, let's not forget about our sponsor, the Alti Association. They're going to be at the high-end show in Munich. And also they'll be cooperating with just before Infocom in June in Orlando. They'll be having another event there. So you put the information right here on the screen and you guys can go check it out on your own. Without delay, let's say hello. Simon's joining us from Japan with some nice pink headphones.
Yep, pretty in pink.
Nice. And Mark Melynkowycz, how are you doing?
Wonderful. Thank you very much. Great to be here.
Okay, so lead product designer from EEDUN. And so doing EEG technology to put largely in earbuds, I guess. Is that the core focus, or are we going into other spaces as well?
No, exactly. We're really looking at how we can take earbuds, in-ear devices to the next level of understanding humans, and that means understanding the brain. So we're at a very interesting point where hearables, or earbud devices, as you say, are really transitioning from being just devices that deliver sound and media to eventually being things that are actually driving applications with, the rise of multi-core processor technology, the ear OS or comm OS systems from companies like Sonical. And we want to be this layer, which then is essentially this glue, which helps understand human intention, needs, and also how the brain is responding to different media. It's a sensor which we really can't measure the type of signal for brain activity in any other way except by really going to the source. And it's really a beautiful complementary technology to the integration of different audio features, AI to enhance audio experiences or the sound landscape around the person, plus having motion. So, for example, having a lot of the functions that you currently have in your smartwatch, but actually putting it into the earbud. Okay. And so if EEDUN, yeah.
Okay, so maybe just to illustrate this, we might walk people through a presentation.
So thank you. IDUN Technologies, it's really a company which is creating a new brain analytics platform for hearables. Now, many times when we talk about hearables, we usually think about sleep. But sleep is one of the most critical problems that we have in our daily lives and also throughout the world. And understanding sleep as a metric and as an entity for being a person is one of the things that we're currently applying this technology to, which sounds a bit strange, when you think about hearables. But when we talk about sleep, when we talk about the evolution of where earbuds are going in the future, it's really interesting to look at the industry. So currently, if you're looking at companies like LG, if you're at CES this year, you hopefully have seen the LG Breeze earbuds. These are earbuds that are also measuring the EEG, or electroencephalography, from the ear. It's actually, their electrodes are a little bit outside the ear canal. And then you also see great products coming from companies like Bose, where you're using musical intervention to actually help the sleep journey of people. And what's missing is really understanding the feedback between what's happening in a person's brain, what they really need, and then how we can change the acoustic environment for them. And you can see these are like very small, highly packaged devices, and that's a big challenge that we have at EEDUN. How can we bring complex neurotechnology into the earbud form factor? Now, for sleep, many people also then make the analogy to wearables. So things like smartwatches that track sleep, and they do track sleep, but they track it in a way that's not as accurate as we get from being in a sleep laboratory. So an Apple Watch, a Pixel Watch, you're going to have things like a heart rate sensor and a motion sensor, which is giving you an indication for where you are in the sleep cycle, but it's not really getting the information directly from your brain. And I'll show why that's super important in the future. So traditionally, if you want to measure brain activity, you're going to have to put on electrodes to the top of your head, preferably glue them. There is dry electrode technology to make it easier, but it's still a rather cumbersome device. And it's not a device which you're actually going to use day to day. And at EDUN, we're really focused on creating this concept of the everyday neurotechnology device, the everyday brain-computer interface. So we actually started from the electrode material from the earbud, and then we use that as a platform to measure brain activity. And that allows us to make things that are very integrated into the consumer lifestyle, like earbuds. And we also have already done validation of our technology. So if you compare this full scalp technology to our in-ear system, you're actually able to measure the brain signal, the brain activity, in a very similar way. So if you think about how your brain actually changes during sleep, you have things like changes in the signal of your brain, the way it's oscillating. You'll have bursts of alpha activity. You'll have changes to deep sleep. And that's stuff that you can't really measure when you look at just the macro architecture of sleep that you get from a smartwatch. And we also see that this stuff can actually be connected up with how people are hearing or experiencing the world. And part of what we do at EDUN is building that technology, but then also building how to understand, how to interpret that signal from the brain. So being able to extract signal patterns for things like the K complex or the sleep spindle, it's a very simple, but ultimately a very powerful algorithm, because if we can do this throughout a night and also throughout the day, we can really start to understand how you're reacting to different situations, and then bring interventions such as acoustics to help you focus better, help you relax better, help you sleep better. We're really looking at bringing this layer to earbud technologies.
And just for the lay person, the sleep spindles and K complex, what are those? I mean, I've heard of REM and some of the others, but
so you can imagine that when you're awake, your brain is at a certain higher state. When you close your eyes, it starts to go into what we call the alpha phase. So you're going from, let's say, 30, 40 hertz down to 10 hertz of your brain activity. And that's really what we measure. So the electrical biopotential at the ear or on the surface of the scalp. And then as you start to fall into actual sleep, your brain waves are going to shift another little bit. So go from about 10 hertz to about 8 hertz or 6 hertz. And then as you start to go into dreaming states, we hear these concepts such as REM, the random eye movement that happens when you're dreaming. These are all markers that we use in laboratory to understand where you are in the sleep cycle. And usually you have to sit there and you look at this on a computer screen, and a technician will sleep stage an entire night. And we're really looking at ways to take algorithms and make this automatic and easy to use, so that this complex history of how your brain is changing during the night can be easily interpreted through this mobile device and then used to build interventions like getting the perfect type of music for you to fall asleep, right? If I like Rammstein and you like, what is your favorite music? Like, what do you use to fall asleep?
White noise, deep house, white noise usually.
Yeah. So some people, it's they're going to fall asleep better, or they'll have their optimal sleep journey. We want to help design that and understand it. And then you can also have your optimal.
Sorry, Mark, you may be going to come to this, but what we're looking at is an electrical signal. Where does that actually come from? You mentioned potential, I think.
So you can imagine that in your brain, you have electrons, and then you also have neurons, right? So a little neuron is going to be, a very small little thing that you're not really going to see. But when they all get together and they start firing, they start creating an electrical potential. And this electrical potential can be sensed on the surface of the scalp. And in this way, we can basically get an indication and an understanding of what's happening inside your brain.
Okay, it's just curious that you take this brain activity electrical into essentially a single, one-dimensional potential voltage, is it? Ultimately.
Yeah, exactly. So you can have many electrodes on your scalp. Some people use up to, I think, 1024. So you can have a very high density, and you can learn a lot about the brain, but then it's something which is never going to get outside the laboratory. And what we're doing is bringing that down to just an ear tip electrode to measure stuff throughout the day. So you can think about it as like a smartwatch for your brain.
Okay.
Thanks.
Yeah, my pleasure. And you can imagine if we can understand a bit of what's happening in the brain over a long time period, let's go from days to weeks to months to years to decades, we can actually start to see how your needs are changing throughout your life. We can understand how your cognition, how your focus is changing. And one of the higher purpose goals is to see if we can connect this up also with disorders that are happening in the brain, ultimately dementia, Alzheimer's. And as you know, also music and dementia treatment, these are starting to be paired together. The idea of music as medicine is also coming to the forefront. And this is one idea that we can connect up what's happening in the brain with the musical intervention that's coming through earbuds. And then we can create essentially a new way for people to live their lives as they're aging. Mm. And when we think about our product, we first want to focus on sleep because there's like a big need in the market, but there's so many ways that we can expand beyond sleep into the daytime activities as well. So things like measuring focus, as well as measuring interactions, like the direction of your gaze, are things we can actually extract just from the ear canal. So we're building a platform in addition to our earbud technologies. We just released our Guardian earbuds onto the market. It's a B2B product so that companies and enterprise can use this technology. They can understand how to integrate it into their businesses, how they can integrate it into their own reference designs. We're really interested in connecting with more companies in the hearing space and the earbud space to see how we can build and integrate these reference designs eventually into consumer products on the market. So beyond just a physical device, we have our brain analytics platform. So we have the ability to stream brain data through a mobile device or computers onto our cloud platform. And this can be done in a variety of ways. We can go directly through our web page. We use web Bluetooth to connect devices to earbuds. We also have a Python SDK, so companies can create more advanced scenarios like playing a type of music, showing a type of media, understanding what happens in the brain during that time, and understanding then how we could do things like personalization of music algorithms. And our application layer within our cloud platform allows us to actually learn different neuromarkers, deploy different neuromarkers, and create a situation where we can have a really seamless experience between collecting brain activity data to building all these new use cases. And then the challenge is bringing that down to an earbud form factor. And this is where I think all these cool technologies coming out, like multi-core processors, are really going to bring, hopefully, a paradigm shift in what an earbud is, and going just from what people consider to be a relatively passive device to one which is really integrated into their lifestyles and is also replacing some functions of their smartphone and other technologies. So if this platform, going beyond sleep, we're looking at how we can do things like acoustic attention with audio. Thinking about gaming, how can we do more hands-free game interaction, or having games that actually adapt themselves to our mental states, right? People get bored of games because they don't have the right balance between frustration of solving a hard problem and the flow of the game environment. So in the future, especially, and this is the cool thing with generative media, right? When we have generative AI creating environments for users in the metaverse, and also when we have acoustic media, which is being generated directly for users, because this is, going to be a next logical step. We see this happening with visual media, like still images. Then it comes to video, and now also the ability to adapt or actually create new musical pieces is also going to be coming. And if we can combine that with our neurotechnology at the ear, it's going to bring some really interesting, very seamless, autonomous new experiences. And also interesting is that when we read brain data, one part is understanding brain state, but we can also understand quite a bit about what's happening with the eye and the face. So we're starting to develop these unique classifiers where you can actually do gaze detection and monitor how the eyes are moving, in addition to doing the brain activity. So you can imagine that when we start to think about integrating more UI or more UX into the earbud, the ability to change the direction of how your 3D audio is being delivered to your brain is one thing that we can start to hook up with our in-ear technologies. And we were recently at the Mobile World Congress as a guest of Oppo at their innovation event, where we could show this technology to people coming from all over the world. And it was really cool and really engaging to see how people are reacting to it. It's still a relatively large device that we're selling. This is really to prove the business case and also the application. And we're really looking for partners to also help us take our reference design and package it into a smaller system. Because integrating the ability to stream brain data with TWS technologies, it's something that takes time to develop, and it's something where we really want to be closer to the device manufacturers to really realize these new products. But a lot of our core technology, it goes back to materials, actually. So one of our key USPs is the ability to measure this electrical brain activity from inside the ear canal. And we do this by developing our own ear tip materials that are conductive, and then we build our product around that. And so doing things like tuning the acoustics of the design, tuning the way that sound is transmitting through the sound channel in our earbuds is also some of the interesting challenges that we have. And then people are always asking, but do you have an interaction between the ear and sound? Is there a problem with measuring brainwaves at the same time as measuring or delivering acoustics? And the answer is no. We have really good performance. So we've basically proved that we can measure the brain in a mobile way in an earbud form factor. And now we want to basically take it to the next step, connect with more people in the industry, and basically see how we're going to build the headphone 3.0, as people call it, and the next evolution of earbuds and hearing. And this really is a great segue into like our roadmap as a company. We started really as a biosensor company. We then proved that we could measure in-ear EEG. With our new device, we're really connecting with all the business cases, POC projects in consumer or in B2B use cases. And then we have a concept for our Guardian audio, EDUN audio, where everything is packaged in a very small device, first based on TWS technology, but we're also interested to see what's happening with LE audio and what's really going to make the most sense in the future for combining the very easy to develop scalable audio platforms together with highly scalable brain analytics. So we want to make the brain analytics easy to integrate into the audio platforms so we can get to the stage where instead of buying a TWS chip, you're buying essentially a TWS/EEG chip where we have our amplifier combined with our reference design for the ear tip and earpiece electrode system. So that's basically our grand vision for the company, and we're very open for having conversations about the future, getting feedback, and seeing how we can all build this future of the earbuds together.
So
you got a question, if you don't mind?
Go ahead.
Of course.
So what I'm saying, there's a couple of components to it. There is the sensor part, and it sounds to me like there's two elements to that. One would be the ear tip itself, where you're getting physical contact, and then there must be another, like an amplifier or some handling of that input. And then the second part of it would be somehow you process that data into. So we've been looking at waveforms, but you're obviously doing something more in terms of analyzing those waveforms to create results from it, essentially. And then another part of the package is what you do with that data, how you interpret it, which would be done generally outside of the earbud. Is that fair to say?
Yeah, I mean, it's a really interesting question, because right now we stream all of our brain data to the internet, and we do everything on our cloud platform for extracting features and then having an API, so that API can talk to your Spotify playlist, for example. I'm also seeing the future where there's going to be this hybrid solution where we have our edge processing device, which could be one of the new multi-core processors coming out. It's providing the ability to potentially modulate audio at the same time as take in and process the brain signals. And then a lot, maybe 40-50% of the processing is happening on the earbud. And then we still have this longitudinal view for what's happening in your life, how are your music preferences changing with your brain activity, how's your sleep changing. and having that really be more in the cloud, so it's personalized. And then also, of course, transferable over all the different digital services through API integration.
Yep. Nice.
Okay. And just on a kind of a legal aspect, is there any issue about the collecting those brain waves, just as in collecting other data? Like, 'cause I can imagine your partners are potentially going to be people like Spotify that curate the playlist and Amazon Music, and they're going to be very interested to know what makes Mark happy, what makes Simon mad, and so so yeah, that's an interesting kind of dynamic as we collect more and more data. Where could this end up?
So we actually have a neuroethics board as part of the EDUN company. And our CTO, Moritz, he has created our neuroethics charter. So when we're talking with B2B companies, we actually go through a process with them to understand what they actually want to do with this data and be sure that things are handled in an ethical way so that we're not, for example, stealing your thoughts or trying to steal the thoughts of people. And of course, keeping the user in control of who they're sharing their brain activity with. Also, when we talk about extracting these classifiers or neuromarkers from the data, this is also another layer of protection. So as we're controlling this full value chain from collecting data to having an actionable insight, then that can also be restricted. So that doesn't mean that just anyone would connect to an API endpoint and be able to access raw brain data. So we have these protection mechanisms in place. And it's also very interesting to see what's happening in different parts of the world with the interpretation of brain data. Right? Because you can also extract tons of information from the smartwatch. The ability to really characterize human behavior and then connect it up with identity is going to be, it's a pressing problem over pretty much all wearables, especially as there's more data collected and stored. So our goal is really to have the user in control, have a process for neuroethics that's also done together with industry representatives from neurotechnology and neuroscience, and really forming, I hope, a standard for how we can sustainably and also ethically build these types of neurotechnology consumer products.
So the current state is you've got this proof of concept. Is that what you would call it, a proof of concept design?
Well, I would say we've definitely gone beyond the proof of concept.
Okay.
So in our roadmap, our proof of concept was essentially the Guardian development kit, as we call it, which was released last year. And this looked more like a prototype product where it didn't really have a lot of scalability built into it. So our current product, we have great scalability of the actual ear tip material. It's injection moldable, it's transferable. Our system for producing hardware, we have much better supply chain. We had a lot of component issues, which was blocking, just the general ability to scale the product right now. But it's definitely beyond the proof of concept phase that we had earlier, and now it's a product which is basically ready to scale. We also have a new product development with a company, Cerebra Health in Canada, where we're co-developing a sleep device for the consumer market in North America and in Europe. So the product is very quickly going towards a mass scalability.
Yep. And so for somebody who wants to get their hands on it, wants to implement it, the model would be that people would license the technology or buy components or both.
So right now for our Guardian earbuds, it's essentially a subscription basis. So companies can come, we discuss, and essentially rent the device on a monthly basis. We're working on a reference design business model for the OEM, for the later business case, where we can have a reference design, license, sell it, and then scale it. And that would include essentially the way that we measure EEG, so the ear tip production, material, and as well things like firmware, the type of potential amplifier to use, and then how to integrate it into earbuds. So we're looking at these two different business cases for scaling.
Okay. So I guess it's be a fairly complicated process to implement at this stage.
Well, I don't know. I think, we're talking with some of the larger companies about how to build reference designs. So it's not that complicated, I would say. It's really about probably changing a few different processes. So, for example, having conductive strips on the earpiece itself so we can conduct to the conductive ear tip, and then having a more standardized way for integrating system-on-a-chip modules with the hardware. And this is also one of the interesting challenges for the future. Will it make more sense to do a die stacking chip ourselves or work with other companies and do more of a system on module approach to the design?
Okay. So it would the device, the current model, Guardian earbuds, it has a fairly powerful processor in it, or is it something that would be that the software would be able to be implemented into existing TWS chips?
Yeah, so we're actually working on a TWS reference design in parallel. It should be ready probably beginning of Q2, so actually quite soon. And there we're actually integrating with a Qualcomm chip. So we have EEG streaming directly into the Qualcomm chip, developed with our partners. And that's going to be our main reference design for doing earbuds at scale. So it's actually almost ready, and I'd love to talk with companies about working with it and adopting it.
Yep. Can I ask a little bit, tell you about this? What kind of processing actually is done? So you're sampling values?
Currently we sample at 250 hertz for the brain signal, and we're not doing too much processing on the device itself because we want to bring, for the development kit, we want to bring a lot of this data into the cloud for doing algorithm development. If we're going towards a specific use case where, for example, we're just measuring a change in focus, these are things that we can more easily do on the device, and where it could make more sense to do it on the device for a specific consumer product. So we're looking more at the, let's say, microcontroller level processing and not needing an 8-core multi-core processor right now to do the product that we need.
Sure, it's almost like two kind of things. One where you would collect an enormous amount of data and offline process that. Another one where you're essentially doing a sample block by sample block characterization, or looking for some characteristic or feature, right?
Exactly. So if we have a neuromarker, such as for focus, and we want to just deploy that one neuromarker on device, that would be feasible. But for our development kit, where many of the customers are still looking for, the application, the killer application that they want to develop for the technology, and therefore we make a much more flexible platform in the cloud, so it can pull in all this data, you can run experiments much more seamlessly, and then do the data science on it.
Yep, very good.
Yeah, so what do you think about this type of idea of integrating brain activity with hearables?
I like it a lot, and all of these type of features going into the earbuds. So heart rate, pulse related, but this one sounds a little more interesting actually for me.
Oh, thank you. Yeah, and really, I see we're going to be integrating all that stuff in the future. Either in our own reference design, if we take it to the third or fourth version, or if we do it together with a commercial partner. Because, of course, I'm sure there are many devices already out there which are doing heart rate. Measuring heart rate plus motion, not too difficult. And then when you add in our technology to that, you have this great combination of understanding what's happening in the heart, the brain, and the body. And I think when we have that, we're going to have a really nice, scalable, powerful system for doing all these things, like also measuring stress, right? Because then you can measure heart rate variability. Then you combine it with your focus. You combine it with, were you taking a walk in the morning? Were you taking a nap in the afternoon after lunch? So I think it's like really an amazing, exciting space.
Yeah, and well, when you're the developer of this, you can see this enormous range of possibilities. But I guess from an implementer's point of view, you might like to choose, I really only want, I'm going to make, for example, sports earphones. So this one specific capability that I want to give to my users. I don't care about sleep, for example. Maybe they do, but you get my point. You want to really try and consolidate onto one specific thing that you get a very robust response out of.
Yeah, and one of the reasons that we started with sleep is that we saw a lot of value that we could bring to the sleep market, so the sleep tech market. And for this reason, and also for the component supply we had at the time, we built this type of device, which was something that has sleep in mind. It's not completely optimized for sleep, so it can also be used during the day as a more normal earbud device. So solving sleep with some of our first commercial partners made a lot of sense from the market. And when we talked to other companies who are in the earphone space, this concept of like, okay, what would be the application for neurotech earbuds? It's still a bit open. And it's really great to see companies like LG coming into the market with these types of devices, because it's first proving that there's an appetite from the industry to bring these new types of technologies. But it's also going to be great for testing the market and understanding how people respond to that type of use case. So they also saw the value in going with sleep first and optimizing their value proposition around sleep. Yeah. But beyond that, once you solve sleep, where you might have earbuds falling out, you have to have good contact, people are moving around, it's being used, for probably 6 to 8 hours already. Then transitioning to those daytime applications like tracking focus, tracking music, that's going to be a lot easier and much easier to scale. And then we want to have, the market proven, having devices in the market for sleep, and then going into these other, amazing use cases is, I think, really going to be the way we go as a company.
That one, do you mind if I ask this concept of focus or concentration, let's say? Is there a metric for that? I mean, is there a way to say your concentration is at a level?
So right now, companies are all doing it individually. It's going to be the same as I think with many of these different applications, that you basically see a change, a synchronization in brainwaves, and doing it together with music. So there's this concept of flow state, where your brain is very focused, you're doing one thing. It could happen in sports, can happen in creativity and creative industries. So seeing how the brain is essentially shifting from one state to another is one of the things that we do with the device. And having a real, let's say, biomarker for focus in the ear and being able to scale that is one of the big things we're going to be bringing to the market. We're doing that right now with sleep, where you're essentially seeing, like I said, these shift in brainwave frequencies to define the sleep state. Yeah. And it's kind of something similar to that for focus.
Be very interested in a study headphone or earphones that can essentially prompt you when you're losing focus, because I don't know if you have the experience too, or when you're working as well. You can fall into a state where you're just not concentrating and just drifting, and an hour could go by. Wouldn't it be nice if the earphone just told you, just go and take a break and come back and regain your focus, rather than leaving you to drift off?
Well, or having your relaxation music or audio start to play automatically, right? So I really love this idea of the work time cycle, where, especially if you're doing like a new problem, your thoughts are like expanding, then contracting, and you need that time. Like your brain plasticity needs that time to think about stuff and then go away from it. And then you have memory consolidation. And there's also a lot of cool research happening in places like MIT, where they're actually looking at memory consolidation during sleep for assisting learning. So having things like having an audio cue when you're learning something during the day, and then bringing that audio cue while you're sleeping. This is one of the research topics where they're trying to see if we can actually improve learning processes during the day by understanding and doing interventions during the night at the right sleep stage. So, I mean, it's still, really in the research phase, but the potential is so amazing to really affect and improve all these different, like, small parts of our lives.
Yeah.
All right. So that's some good stuff. Very interesting stuff, Mark.
Thank you.
Thank you for joining us today. We'll put some information down below for people to follow up and find out more information on EDUN. And so everybody like, subscribe, share, all that good stuff. And we'll see you on the next episode. See you for now.
Cool. Thank you, Sam. Thank you, David.